Assalamualaikum and hello everyone. Me and my friends are here to present our innovation for IFIC 2025, which is reverse logic analysis on athlete injury data using supervised random higher satisfiability. And this project is designed to help coaches, healthcare professionals, and also athletes themselves to prevent sports injury through the power of explainable artificial intelligence, which is AI. But before I explain how it works, let's look at the problem we are trying to solve. In the world of sports, injuries are one of the biggest threats to an athlete's career. Every season, many athletes from school-level players to international professionals are forced to miss competition, lose performance, or even retire a year due to injuries. So many of these injuries are actually preventable if detected earlier. So the challenge is that current injury prediction methods are either based on experience alone or use black box AI models. And these models can give a result, but they don't explain why. Without knowing the reason behind a prediction, coaches and medical teams cannot make confidence or targeted decisions. So this is where our innovations comes in. To solve this challenge, we developed RAN3 SATRA, which stands for Random Tree Satisfiability Reverse Analysis. It is a logic-based AI model that predicts injury risk and, most importantly, explains the reasoning behind each prediction. Traditional AI works like a black box. It tells you yes or no without showing the logic. RAN3 SATRA is different. It generates clear if-then rules that makes its decision easy to understand for coaches, sports scientists, and also athletes themselves. And the model uses clause size, which is k equal to 1 for a single condition, k equal to 2 for pair of conditions, and k equal to 3 for more complex three-condition patterns. And this approach allows the model to detect both straightforward and hidden risk factors in the data, making it flexible, accurate, and also transparent.
Next, we will show to you guys how our model works to identify the athlete injuries. We get our dataset from a Kaggle, and it mainly focuses on athlete aged between 18 to 25 years old. It contains a various attributions starting from a basic information like age and gender, and also a performance-related metric such as a training intensity and also hour trained per week. And it also includes a calculated score like the load balance score and also SEL risk score. In the data pre-processing stage, we will explore the correlation between these variables to find the top 10 most influential attributes related to the performance and also risk injuries. These attributes will be focused on in our analysis.
This slide explains how higher order satisfiability works in our dynamic Hopfield neural network. Under training phase, we start by feeding the dataset input in bipolar form into the network. Then energy function measure how stable the network is. Think of it as checking if the system has reached a balanced state. Next, we calculate the local field, which is the weighted sum of inputs from connected neurons. This helps determine each neuron's activation based on the influence of others. We also use content addressable memory or CAM to store stable patterns in the network. This means the system can recall and recognize patterns that it has already learned. Under testing phase, the objective is straightforward: to find the best logic rule that maximizes classification performance by selecting the highest possible total of true positive and true negative. In other words, we are training the DHNN not to just predict the outcomes, but also using the most reliable and interpretable logic patterns.
For the simulation, we begin by setting up the model using our coded program for RAN3 SATRA, and the first step was to figure the clause sizes, and which is control how the logic rules are formed from simple single condition to more complex multi-condition patterns. Next, we prepare the dataset by renaming and loading the file containing the athlete injury and performance data into the program. Once everything was in place, we ran the program to execute the model, and the system processed the data, applied the logic mining method, and produced the final result, which is a set of interpretable rules along with performance metrics such as accuracy. And this result confirmed that the model can deliver transparent and reliable prediction for injury prevention, and they will be discussed in the next section. For the simulation,
Hello everyone, I want to talk about the result of the induced logic, where it refers to a process where we automatically derive these kinds of rules from a set of data. These fast-fit rules could be used to classify something based on the combination of different features. The number you see below are the result of a test we ran on this induced logic. This means we had 3 true positive and 0 false positive. In simple terms, the model correctly identified 3 instances of what it was looking for and made 0 incorrect positive classification. Next, we also had 17 true negative and 0 false negative. This means the model correctly identified 17 instances of what it was not looking for and didn't miss any of the positive cases. Now let's look at the result of these numbers, where accuracy equals to 100%. This means the model made 0 error across all 20 of its classification. Sensitivity equals to 100%. It correctly identified every single positive case, and specificity equals to 100%. Also correctly identify every single negative case. And the second last is negative predictive value, NPV equals to 100%. This tells us when the model predicts something is negative. And finally, we have the MCC equals to 100%. Is considered a very reliable metric because it takes into account all 4 values. And the 100% indicates a flawless prediction. In summary, this induced logic model has demonstrated perfect performance on this athlete injury dataset. Thank you.
This project benefits three key groups in sport: for coaches, for athletes, and for sport psychotherapists and healthcare professionals. First, for coaches, it enables data-driven training load management, helps identify high-risk players before competitions, and supports smarter substitution and rotation to keep the team at peak performance. And for athletes, it allows early injury risk detection, personalized training adjustment, and ultimately longer careers with improved performance. And the last one is for the sport psychotherapists and healthcare professionals. It provides clear injury risk indicators for targeted rehab, threat recovery process through the data trends, and boost mental readiness by reducing the fear of the re-injury. In short, it's about safer athletes and smarter coaching, and the last one is the stronger recovery.
To make sure this innovation creates real impact, I took it beyond research and into the community, focused on young athletes and school sports club. And throughout these sessions, I introduced the concept of logic-based AI and also demonstrate how Rentrisatra can help prevent sport injuries. What I found most encouraging was that even non-technical participants could easily understand and apply the if-then rules generated by the model. And this early exposure not only raised awareness of AI's rules in sport safety, but also empower athletes and coaches to make smarter, data-driven decisions for performance and injury preventions. To make sure this innovation creates real impact, I took it beyond research and into the community, focused on young athletes and school sports club. And throughout these sessions, I introduced the concept of logic-based AI and also demonstrate how Rentrisatra can help prevent sport injuries. What I found most encouraging was that even non-technical participants could easily understand and apply the if-then rules generated by the model. And this early exposure not only raised awareness of AI. In conclusion, Rentrisatra transformed athlete injury prevention by combining high accuracy with transparent logic rules. Tested with the perfect simulation result, it empowers coaches, healthcare teams, and athletes to make safer, data-driven decisions. With further development, this model can be integrated into sports analytic platforms to protect athletes across all sports. I think that's all from us. Thank you. From logic to prevention, empowering safer sports with AI.